Welcome once again to the lecture series on Zener Diode. In our previous lectures, we have discussed the basics of Zener Diode. We have seen how Zener Diode works as a voltage regulator. We have taken two problems, and the link for all these videos I'll put in the description box as well as in the I button. Now here we'll be taking another problem, and here mainly we'll be focusing on the line regulation. That means the voltage source is varying. The input voltage is varying from 15 volt to 25 volt. Here you can see that the resistor value, R value, is given as 600 ohms, and it is said that the Zener breakdown voltage is 12 volt. So under these circumstances, we have to find the input value of the minimum and maximum value of the input current. So this is our input current I, which is getting branched here as IZ and IL, but it is given that the Zener breakdown voltage is 12 volt. So as a result of that, if we take output from here, the load VL, which is also equal to Vz, so that we have 12 volts. Now to find the minimum and maximum value, we have to consider the minimum and maximum input voltage. So input voltage V in minimum is given as 15 volt and V in maximum is given as 25 volt. So if we apply KVL here, then we can write that 20 or say minimum one 15 volt, that is equal to I into R, I mean into R, plus 12 volt, which is Zener voltage. So from here, if we solve this one, we can find the I mean is 15 minus 12 divided by R. So that is 3 divided by 600. So minimum input current, if we calculate this, we can find as 5 into 10 to the power minus 3 ampere, that is 5 milliampere. Now if we try to find the maximum input voltage, that means maximum input voltage whatever is given, on the basis of that maximum input current we can find. So I max, that will be, once again we can find by applying the KVL here. So for that okay, so let us first apply the KVL, and we find that 25, that is equal to I max into R plus 12, because this is not changing, this will be fixed. So now as a result of that, we have I max as 25 minus 12 divided by R. So that will give us 13 divided by 600, and we'll get maximum input current as 21.667 milliampere. So minimum and maximum input current we have found. Now the second part of this problem is saying us that RL is now 3 kilo ohms. So previously this RL value was not given, and we were only concentrating to find the input current. Now RL is given. Now since RL is given, the output voltage, which is 12 volt, VL, which is 12 volt, which is a fixed one, it is not changing. That is the concept of Zener voltage regulator. This is not changing. So that means the current through RL, which is IL, that shall also not change. So under these circumstances, we have 12 divided by 3 kilo ohms. So IL value we are obtaining as 4 milliampere, which is fixed. This is not changing. Now we can see from this diagram I is equal to Iz plus IL. So that means we can write it like this: I is equal to Iz plus IL. IL is now fixed. I is having some minimum and maximum value. On the basis of that, the Zener current also will be having minimum and maximum value. Now for I minimum, we will get Iz minimum, whereas IL is fixed as 4 milliampere. So I minimum is given as 5 milliampere. So Iz minimum from this we find as 1 milliampere. So very much straightforward. In the same way, if we calculate the I Z maximum, for which corresponding we have I maximum. So here we find I Z maximum plus IL. So IL value is not changing. I max value is given as 21.667 milliampere. So on the basis of that, we will be calculating Iz max. So Iz max we are getting as 17.667 milliampere. Now what is the observation out of it? We can find that even though the input voltage we are varying, output voltage is not changing. So that is the first and foremost thing of the Zener diode as voltage regulator. And second thing, we find that output current is also not changing, while the current through the Zener diode is changing. For the same voltage, once we are getting 1 milliampere, whereas Zener breakdown voltage is 12 volt, it is fixed. 1 milliampere based on the input section for 15 volt, we are getting 1 milliampere as the Zener current. And similarly, when we are making the input voltage 25 volt, Zener voltage is 12 volt once again, but the Zener current has increased to 17.667 milliampere. So that is another fundamental concept of the Zener diode as voltage regulator. So we end our discussion here. Thank you.